yeah, so this is a very common function which happens to be the most common. So you can have fun if you like it. Okay. Okay, maybe I should write down the reference now because we will already say it. So this is, well, the book I forgot the title. I know it is. There might be just isolated articles or papers for them as well, and then there's so the Morse code lemma is a generalization of Morse lemma for Morse code function that locally has this code system. This one is again Python. This is easily available on the internet. It does not have an archive number. I don't know. I didn't search to see whether it was finally published somewhere, but it's widely available. It's easily the same thing. There are many proofs of this. They sort of give a proof using some ideas of Richard Palais, which probably gets used elsewhere as well. So, short thing where the essential kind of Morse code lemma using some techniques bypassing the atoms. So it's not just a parameterized version of Morse lemma. Anyway, so let me use these Morse code functions as examples, and in particular this to state a theorem. In some sense, you might call it a generalization of Leibniz theorem, although you can generalize it perhaps in many ways. So what do I mean by generalization? Well, you could say, is there a theorem which says what happens when I have three critical points? That which I don't know, or a critical point. That might be too much to ask because you have no control of what the topology of it looks like. We say K is fine. So to just go from 2 to some arbitrary K, that may not be a tractable question. So what we are going to do is we are going to say that okay, we have a Morse code function rather than a Morse function. So it will have a critical set. But we are going to impose that the critical set has two components. And I'm sort of lying here when I say two components, you will see in some cases it might have three. But what I essentially mean is the Morse code function should have two sets. Each one of them looks like a sphere of certain dimension, but they're not the same dimensions. This is SK and SK. And then the claim would be that the original manifold that we started off with is an n sphere. Topologically, n sphere at the n is one more than the sum of the dimensions of the two spheres. K plus n plus 1. So the dimension of n can be sort of, you cannot know it anyway, but it can be deduced as a consequence of the dimension of the bigger sets. And it's also a sphere. So it's a generalization in that sense. I'm not saying that the critical set will always have two components, each is a sphere, because I'm thinking of S0 as a sphere. It's the zero sphere, but it does not have one component, two components. But so when I say two components, I'm sort of using the Euclidean notation. Each component is a sphere, but the sphere is connected or not, you know what a sphere is. That's correct. Yeah, so this is drawing for Satchidanand Prasad. So this says that so whenever I say compact again, it means closed without boundaries, like in the case of Leibniz theorem. Manifold and homomorphic to subsets, each being homomorphic to topological space. Okay. And I'm going to assume, you'll see, I erase this example. So, yeah, your first assumption is that it's more spot, and the second is that the critical set is the disjoint union of two submanifolds, each being a sphere. So if k is, you can assume k is less than n, because one of them has to be bigger. K is 0, then this is S0, so it's 2 points. Otherwise, if k is bigger than 0, then this is obviously bigger than k. So they're both actual spheres, so there are two numbers. Yeah, if this what works this way, this is okay. So let me make a couple of remarks, and then maybe some comments about proof. The proof, as it turns out, is not that hard. Technically, it's just a combination of various things from basic algorithms model. But let me make some remarks. First of all, you might say, okay, are there examples of such functions that you know? Well, here is one. This is a mode spot function, exactly with the two kind of critical things. Your k is k, and your well, yeah. So L is n minus k minus 1. And if you add both of them and add 1, you get n. And so here, of course, there. I mean, this actually includes more examples. So I could imagine an n of which k was equal to n minus k minus 1. Here's one distinction that this has to be non. Here, in proving this, you need this. Because if you drop this, this will not be good. You need one of them to be less than 1. But this gives you examples of such things. So the standard sum of squares functions indexed appropriately will be a mode spot function. With this, and continuity. So if you take S3, this is S1, this is S1. And you get a mode spot function with S1, with S1 and okay, so in fact, if you want an example where this is 0, just if you want 3 components, this is S0 and then this has to be Sn minus 1. You already know of an example. But it's this, but this is also the equal height square function. Take the height square, the equator becomes a critical set and the two poles are already critical sets. That is also subsumed by the first example, h squared. Okay, the two is you need this because we've already seen an example of a function on a torus, which was more spot. The critical set was two circles. They're disjoint, so S1 and S1, but obviously the torus was not even of dimension 3. It's not, even if it's of dimension 2, even if you drop this, it's not S2. So or k less than that. That's kind of the point. I mean, if you don't want to put this, then you want to have to put some constraints to possibly get something. That is one. No, constraint on some other topological constraint in case. Because see, the point is, if I drop this, like when I say that I am looking for a manifold with a mode spot function which critical sets and 2 copies of SKs, the first place you look for constructing such a function is you look for any Sn, any sphere. You can so for those of the seam bundles, you construct any SK bundle over Sn, and then you can numerically sign function. This has 2 critical points. So this function is mode spot having 2 critical sets, both are SKs. But I mean, usually it's going to be a rare case that this is actually monotopic to a sphere, it is a sphere.